So my name is Sarah,
My name is Danny.
and our presentation is called A Leg Up. It's about a self-powered prosthetic leg. Regeneration is really key in not only human life, but also other organisms. Every day we regenerate our skin, we generate our blood cells. We really not only regenerate physically, but also down the line, also in birth rates, such as reproduction and everything. Regeneration is key to an organism's life. It's also can replace, like if a lizard or something like that is caught by a bird, it's able to get rid of its tail, so it is able to escape. And later down that road, it's able to regenerate that tail, such as creating a limb or organism called a blastema. Unfortunately, humans are not able to do this, sadly. That's why we create prosthetics, so we are able to do something like this. We do have blastema in our body system, but when we are in embryo form. But later down that road, the blastema goes away, and we are unable to regenerate our organisms and limbs again.
So what is a prosthetic? Prosthetic is simply just a fake arm or a leg, something to have for if when you lose yours or if you don't have one in the first place. They could be something simple like it straps onto your arm and connects to like your shoulder muscle, so when you move it like the hand will clamp. It could be like, let's say you lose your leg like below the knee. It could just be like just the shin to help you walk again, just to help people do everyday things. Right now, prosthetics are at a point where they are making them controlled by your mind, so you could easily like flex your fingers. But what we're focusing on more is artificial touch, which is small pressure sensors in the hand, or what we want to focus on is the foot, where as you touch something, it'll activate the sensors, it'll send a signal, which will use electrons to stimulate nerves in whatever missing part of the body you have to create artificial senses in your brain.
A more realistic approach that we can take is creating a shin or a lower body limb that is able to sense or have sensors at the bottom of the foot and at the main points, such as where I showed out right over here. I had to make them symmetrical because that's how the human body works. Like if we want to sense something, it's symmetrical. And then right down here, how the battery's stored right here, and it's in the prosthetic will be made out of carbon fiber. We have yet to figure out what the protective material would be on the bottom layer. We have to do some more research onto that. That won't affect the sensors at the bottom of the foot. Now, this is never mind.
So we want to add self-charging units to these prosthetics so that they'll be able to power themselves, be more self-sustaining. So it's more like if you actually regrew a limb somewhat. Like if you have like a prosthetic that you have to like take off every day and charge it, that's not like realistic. It's not like close to regrowing it. If it's self-charging, then it's closer to the real thing. And for self-charging, we think the most effective means would be to use kinetic charging. For that, it would you would have like something like an induction coil inside, and you would have a magnet inside the induction coil. As you move throughout the day, so like if you take a step, the magnet will move throughout the induction coil, creating pulses of creating pulses of magnetic charge, which will turn into electric charge, and throughout the day, charge a battery. Approximately 30 minutes of jogging or 10,000 steps could charge about 1,000 megaamp, which in turn could, if you compare it to your phone, charge it about 50 to 75%.
Now, now these, it's gonna, about a time period that this will be able to take is actually, gonna be about 5 or 6 years in the future to be able to create something like this. It's in the future, but, closer to the future, but close future. Now, we can, have about, if we, to save some power or anything like that, if the human or person who has the prosthetic foot wants to be able to have more power, they can easily turn off the sensors, so they can just run on kinetic energy and be able to have more of a power extension for their ankle to be able to move. Yeah, that was really it.
So, specifically, who is this for? Because there's a lot of people who may like get a leg amputated or lose a leg, but there's a lot of them who they could be lazy, they don't care about feeling their feet anymore. So it's specifically more for people who are active, who may be like, oh man, I miss feeling the sand of the beach on my toes. It's specifically for people like that. So if they're lazy, they won't move around enough to charge the battery at all. So they wouldn't even need the self-charging unit.
I think that's our sources, and I think that'll be it.
Okay, so it's time for questions, guys. So many questions. Okay, one at a time. You guys make the call.
In terms of having the prosthetics feel again, would you have it set so that it can actually feel pain or distinguish pain from other things and then neglect it? Because some people would rather just feel things, but they would rather ignore pain.
We haven't really put much thought into that, but
I think that pain is subjective because you feel pain as a sense of danger, but if it's a fake prosthetic, I don't know if that could even feel pain in the first place.
Okay.
Alright, so usually when someone loses a limb and they have to get prosthetics in general, it takes months, maybe even years of physical rehabilitation to be able to use prosthetics to begin with. Given that you're having extra sensors, that's also a lot of surgery and unpleasantness. How quickly do you think they'll be able to use the prosthetic limbs after they've been implanted?
well, actually, part of the prosthetic is actually made in 2011. There was two things. There was a TED Talk that actually came out that already had the sensors that were not really like gone through surgery. It was more of part of the prosthetic, and also the second part was back also in 2011 they created the self-charging leg already. So really we took those two ideas that have already been made and proven that they do work, and we're going to combine them.
So can I ask for clarification here? In the self-powering, and I'm a little confused here. It sounds at certain points that you're describing a powered actuated limb. In other words, one that responds mechanically. But then I also hear about the sensing aspects. Can you clarify precisely which approach you were looking at? Again, there's a big difference between something that's mechanically actuated and primarily a sensing application. I apologize if I've heard this wrong, but please educate me here.
The goal was to to take the sensing technology
Mhm.
of a prosthetic limb and add in the self-charging to make them utilize each other to make it self-sustaining. So like, because if someone has like a limited battery on like a prosthetic foot so they can feel, it'll run out over a set amount of time. So the point was to make it so that it doesn't run out over a set amount of time.
Okay, all right, so this is not a mechanically actuated flexing thing or, you know, pushing off on your tip of your toe or something like that. It is solely for sensing applications, is that correct? Tactile sensing, things along that line?
Yes.
Okay, good, I just wanted that clarification.
Okay, so I guess my question is in line with actually what Connor was telling you. So one of the key things I think that you have to probe more to get into this is because you're basically sensing and you're hoping, right, that through this touch or whatnot is you actually can send signals to the brain, so then the brain can now have a detection of, oh, this is a sand feel, or now the thing with that is your brain basically our brain is able to now delineate the different senses. You have this, you know, whether it's good, it's pleasing, or it's painful, or that's when now it comes in. How is the brain going to be able to differentiate all these different types of feeling that your sensor is sending to the brain? And I think that is actually this is a very good start to do that. But I think you have to probe into the biology aspect, right? And see, okay, what type or, you know, of frequency, let's put it into because this is more in the kinetic aspect, right? What frequency is actually sensed by the brain for the brain to say, oh, this is a pleasing sensation, or this is actually an irritating sensation for me, because that's not part of the body system now. It's an external system that's sending something to the brain, and therefore the brain has to somehow know, okay, what is this? Is this considered by the brain as something pleasing or not? So yeah, Connor, I think's point is actually very important to take into
And
consideration.
if I can, you know, amplify that or maybe distill that down a bit, what is the interface between the sensing that goes on to the limb
And the actual.
the physiological aspects of the nervous system?
Mhm.
All right, how is that? What's the nature or proposed nature of that very critical interface between the physical aspects of the artificial limb and the intact aspects of the human nervous system? Do you have an idea? Can you articulate that? How do they communicate?
From what I read online, all I could really know is that they have the sensor, it communicates to a computer, that computer sends a certain type of signal, because so far they've been able to identify with artificial touch and like a hand, difference between like smooth and rough surfaces, soft and hard objects.
I would like to see more on how that works.
That actually, so there is already a literature on that.
Yeah.
So you have to put that in, incorporate that in, and incorporate, like Dr. Mady is saying, it's still not very clear as to how exactly is the processing of the data that is taken, for example, from the computer sent to the brain itself. You know, there has to be an interface of, because the body is still an existing, naturally occurring, physiologically functioning body. And then you're basically incorporating an external thing that is supposed to be processed internally as well. And so that's what Dr. Mady is trying to ask you, is make sure that when you present that later on, that is put in. Because right now, it seems like, yeah, the concept is very good. Okay, I really like the idea. It's a matter of, it has to be in a way where we can see, okay, how does this actually really connect, and how does this actually really get into action? Does that make sense, right? I think that's what's missing a little bit there. Okay, and like you said, you have read in the literature already those aspects. Those are very critical in the putting something of your own addition to what is already there, so that we can, you know, see, okay, this is a good advancement now of what's in place. Okay, because I think that should be, like you said, they already have that, where it can actually now sense a rough from a smooth, you know. So I think you can start from there and then add something else, maybe. Yeah? Yeah. Any other questions in the class? That is very awesome idea. All right, if there's none, thank you guys, and please give a hand to Dr. Macy.